In this video, we're going to be talking a little bit more about similarity. We're going to talk about some new vocabulary and get some more practice in making those proportions that we know and love so well. So recall that when two triangles are similar, they have the same shape but a different size, right? So what that means is our two really important conditions are that corresponding angles are congruent, right? But corresponding sides are are in proportion or they're proportional. So make sure you understand those two things. You guys might be asked to write the definition of similarity in a future assessment, so make sure you understand those two conditions. So we want to make sure that we are taking advantage of these like shortcuts that we're giving you. So when you have a diagram where your triangles don't look like they're in the same orientation, you should always draw them because that helps you easily identify corresponding pieces. So if the names are written out for you, like for example, here we have triangle AEC is similar to triangle BED. So when the question writes them out for you, you can use the letter trick. Now you use the order of the vertices to kind of figure out what goes with what. So what I like to do is I'll keep one triangle the same. So I'm going to keep triangle DEB or triangle BED. I'm going to keep that the same so that I only have to worry about flipping one of them over. So I know that with this blue triangle here, I know it's a little bit bigger, so it doesn't really matter how we draw it. We just want to really be mindful of where we're putting the vertices. So kept one the same, filled in all the letters. Now in my other one, I'm using the letter trick. So for B, for example, B comes first, A comes first. So I know that B and A need to be in the same general location. So I'm going to put A there. Now we have E and E both coming second. Now it might seem silly to you, you're like, yeah, it's E, so it's gonna go in the same spot. That might not always be the case. So you always wanna double check to make sure that they're actually in the same order. And then last but not least, we have C and D. So D is here, and I know that C needs to go in the same general location. So this is my triangle. Now a reason why we say to do this is because if you look, let's say if you look at DE, right, you can see right away when you redraw it that CE is the corresponding piece. However, if you highlight those two sides here, those might not look corresponding in the diagram that we have. So you want to make sure you redraw them so that you don't make silly mistakes. All right, this is a slightly more complex diagram, but this is going to be a case where the letters of the triangles are not written out for us. So this is where we're going to be matching up the location of the congruent angles. So again, redrawing our triangles, if they are not in the same orientation, this needs to be done every time. Because if you don't, you're doing yourself a disservice because you're making yourself more likely to make a mistake. So let's label our given info. We have that in triangle CHR, angle H is congruent to angle RDO. And that's all we're given right now. So we've dealt a lot with reflexive property when our two triangles were sharing a side, but they might also be sharing angles as well. So you can kind of see that in this triangle right here, it's taking the entirety of angle R right here. So angle R is both in the larger triangle and in the smaller triangle. So we're going to go ahead and label that with 2 arc marks. So I'm going to go ahead, again, we choose one entire triangle to keep the same. I'm going to choose triangle CHR to be the same, and I'm just going to worry about changing triangle RDO. So I'm going to carry over my markings, right? In triangle CHR, we had 1 arc on angle H and 2 arcs on angle R. Now in my second triangle, I know that it's smaller, right? This is where we're matching up our congruent angles, right? So for example, my single arc is in like the bottom left of my triangle. I'm going to want my single arc to be here as well, right? Now in my smaller triangle, in triangle ODR, that singular arc, that's angle D. Now my double arc, I want on the bottom right here. In my smaller triangle, that double arc is R, and then we have angle O, last but not least. So again, this helps you identify your corresponding parts. For example, CH, right? Clearly, we can see that CH and OD are in the same general location, right? So we know that these are corresponding. However, if you look at your general diagram, right, and you look at CH and OD, right, that might not be as obvious. So that's why you want to make sure you're redrawing your stuff so that you can easily identify your corresponding sides and angles so that your proportions are just a little bit easier to make and you're less likely to make a mistake. Now we're going to get onto some of our new definitions. So we have scale factor, and we have this wording map onto, right? So these are just fancy words. So we say that similar triangles can map onto one another. That just means that they can land directly on top of one another, right? So it says if your two triangles are different sizes, then one triangle can be mapped onto the other one by a dilation. So a dilation is like a scaled image. To create a scaled image, we must multiply or dilate by a scale factor. Now, a scale factor is just a number that we're multiplying every single component of an object by. So, for example, this smaller triangle here, right, can map onto my larger triangle if I multiply all of the sides by a scale factor of 2. Now, in another color, let's go backwards. So this larger triangle can then map onto my smaller triangle. Remember, map onto just means it's going to land directly on it, right? Or like, think about it in terms of like, we can get all of these 3 sides of this triangle to become equal to all the 3 sides of this triangle by multiplying it by a scale factor of 1/2. So there are some generalizations here. If we're going from smaller to bigger, right? So in this red example here, we went from this smaller triangle to the larger one. If we're making our triangle bigger, our scale factor, or that number that we're multiplying all 3 of our sides by, has to be greater than 1. Now, if it was the opposite, if we are going like this blue example, if we're going from a bigger triangle to a smaller triangle, then our scale factor, or the number that we're multiplying all of our sides by, has to be less than 1. For example, like 1/2, right? We're dividing all of those sides by 2. So that scale factor is less than 1, which means our triangle is getting smaller, right? So in your task card or in practice questions, that's a good way to check, right? If you create your scale factor and you know you're going from a smaller triangle to a bigger triangle, but your scale factor is less than 1, that's kind of a way you could be like, hey, wait, I know my scale factor should be greater than 1. And it kind of gives you another way to self-assess. So let's try some examples. So the 2 triangles below are similar. Find the scale factor that will map triangle ABC onto triangle A prime, B prime, C prime. So my first method of attack here, we're going from ABC onto this one. So I know I'm making my triangle smaller. Now what that tells me, just by thinking about our vocabulary words, my scale factor is going to be less than 1. I know I'm going to be multiplying by a fraction here. So the good thing about finding scale factor is that you guys kind of already know how to do it. So if you remember from making our proportions, right, like let's just make our proportions. So here we would have A prime, B prime, right, over our corresponding side, AB, equals, and this is using a method, this is using the method 1 that we talked about, and then we have A prime, C prime over AC, right? Each fraction in these proportions is going to help you find your scale factor. For example, let's fill in our values here. So A prime, B prime, this is X, over AB, which is 9, equals, then we have A prime, C prime, which is 2 over 4, right? So right now we don't have a value for X, but 1, we already know how to find that, right? Using our prior knowledge, we can cross multiply and actually solve for that value of X. And if we did that, right, if we cross multiplied and solved, we would get 4X equals 18, and then we would get that X is equal to 4.5, right? So now I know that AB is 4.5. Now, if we rewrite our proportions, we have 4.5 over 9 equals 2 over 4, right? If we simplify either one of these, we're going to get a fraction here. If we simplify, we get 1/2. Here we get a fraction of 1/2, right? So in our proportions, if you simplify just one of those fractions, you're going to get your scale factor here, right? Now, some people might make the mistake, and when they're making their proportions, they might go ahead and instead do maybe like 9 over X and instead maybe do 4 over 2. And if you did that, you would simplify and get your scale factor of 2. And I'm going to put a question mark there because when you get something like this is why you analyze your problem first, right? We said that our triangle is getting smaller. So we know that our scale factor should be less than 1. So if we set our proportion up like this and we get a scale factor of 2, immediately that should be triggering something in your brain, right? You know you put the wrong sides in the numerator. So if you get a scale factor greater than 1, when it's supposed to be less than 1, you can kind of go ahead and reassess the proportions that you make. Now, last but not least, One more time. So we want to find the scale factor that will map triangle PRQ, which is here, onto triangle SUT. So I know, again, my triangles are getting bigger. So I know my scale factor has to be greater than 1, right? And again, this is just a way that we can self-assess. As mathematicians, we want to make sure that we can always check if our answer is right without just having to guess, right? So again, when we're making our proportions, we can do PR over SU, right, equals, and then we can do PQ over ST. Now notice I'm not using the third pair. You don't need to, you can, and that would just be another way to check, right, that your work is correct, but you don't need to use the third side. So let's fill in our numbers. We have that PR is 8 over SU, which is 12, and then we have equals PQ, which is 10 over 15. Now if we simplify both of these, we're going to get 2/3. Now I have a problem here. There's a problem with how we made our proportion, right? Here, this is my scale factor. My scale factor is less than 1, but we said over here that since my triangle is bigger, since I'm mapping the smaller triangle, I'm trying to get that smaller triangle onto the larger one, my scale factor should be greater than 1. So if this happens, what you can do is just flip that fraction around. My scale factor is going to be 3 over 2, right? So if I multiply all sides by 3 over 2 in triangle PRQ, I will map that onto triangle SUT. So same thing goes, right, with that last slide too. If we went ahead and did, if we made our fraction 4 over 2, right, for these two sides, and we simplify that, if we get 2, and we know that our scale factor is going to be less than 1, what you can do is just find the reciprocal, flip that number around. So for example, if our scale factor is 2, that's the equivalent of writing 2 over 1, right? So if we flip that around, the scale factor would actually be 1/2. Okay. So make sure you guys understand our new vocabulary. Make sure you guys are utilizing that method of redrawing our triangles, because we're going to do that again here, right? So it says, in the diagram below, the two triangles are similar. It wants us to calculate the length of AC and then determine the scale factor. So right away, I know my two triangles are not in the same orientation. I'm going to do that. So I'm going to keep triangle ECD the same. And then I am going to draw another one. Let me carry over my marks. And now we have to match up our congruent angles, right? So I know my double arced angle is in the left side. That's going to be, maybe we should do this in a different color. Let's do it in blue. That's going to be this triangle here, right? So my double arc goes in that bottom left. My single arc goes on the right, and that's angle A. And then we are left with angle C. So first we want to find the length of AC. So let's fill in what we have. We have that EC is 70, CD is 80, and then we have that CB, which is over here. Now that is 35. And we want the length of AC. Whatever you're trying to find in a question, I would put that as X, just so you can kind of visibly see the proportions that you're able to make. So I'm going to go ahead and start. We're going to do 70 over 35 equals 80, which is here, over X. And then if we cross multiply, we'll get 70X equals 80 times 35. I'm left to try to do this in my head. 210. Okay, hold on. It's 2,800. And then you want to divide by 70 on both sides, and you will get that X equals 40, right? So CA is 40. Then what we can do is we want to find the scale factor, right? And in this case, let's go from this blue triangle onto the bigger one, right? So here, my triangle is getting larger. So just by a guess, I know my scale factor needs to be greater than 1, right? So again, I said if you simplify any of the fractions from the proportions that you make, you're going to be able to find your scale factor, right? So I'm going to choose this one. If I simplify that, I'm going to get 2, right? And we can double check that, right? If I multiply BC by 2, I get 70. If I multiply this value that we just got here, which is 40 by 2, I get 80, right? So my scale factor is 2 in order to map triangle ABC onto triangle ECD.